Okay, this is video 1 for Introduction to Algebra. So my approach to teaching algebra is pretty simple. I like to keep everything easy to understand. Hey, turn that off! Okay, so this is video 1 for Introduction to Algebra. The way I teach algebra is we're going to start with something called a number line. Okay, this is video 1 for Introduction to Algebra. So let's just start with the basics. Okay, so algebra is going to be made up of constant terms. So like, let's say a number, here's a 2. We see that that's a 2. It's always a 2. 2's are always worth 2. Then we have something called variable terms, and we're going to use the one that's most commonly seen, x. The other one most commonly seen is y. So this is generally because of something called the Cartesian graph, which you will also need to know about. So you have a y-axis right here. This is an axis. Here's an x-axis right there. This side of the x-axis is positive. This side of the y-axis is positive. This side of the x-axis is negative. This side of the y-axis is negative. So this is called a point of origin. It is 0. And then it goes -1, -2, -3, -4, so on for infinity. This goes positive 1, 2, 3, 4, so on for infinity. And the same true for y, so positive 1 to infinity, -1 to infinity. So this is called a Cartesian graph because it was developed by a person by the name of René Descartes, a French mathematician and philosopher. So we've covered most of the basics. We have something called ordered pairs here. X, Y are your ordered pairs. So when you're solving linear equations in two variables, one's going to be X, one's going to be Y. We'll talk about finding those in terms of coordinates. So if I give you, this is, by the way, this is the standard notation for that, or convention for that, which means X then Y. So if I give you 2, -3, this 2 represents, as you see, X, and the -3 represents Y. This is by convention here, meaning just the standard way everybody does it. So you're going to go to positive 2. Positive is implied if there's no plus or minus sign in front of it. We assume it is positive. If it's negative, it will have a negative sign in front of the constant term or the variable term. Now, we would go to positive 2, 1, 2, evenly spaced, assuming. And then we would go to -3 on the y-axis, and we establish that this is the positive y-axis, this is the negative portion of the y-axis, this is the point of origin of the y-axis, which is at 0. So we'll go -1, -2, -3. So then we make a straight line, and we have a nice 90-degree angle, which is represented by a square, and we'll right in the middle of 2 rays. And this is our coordinate. We coordinated between X and Y. So that's our point right there within the graph. And then if we had multiple ordered pairs, we would find all of them on our graph, and let's just say they went like so. And so then we would play connect the dots as we did as little kids, and we would see the way they behave. Now they might create a parabola, or excuse me, a straight line, a parabola, which can be any different direction. So we've covered constant term, variable term, ordered pairs. Now let's talk about something called coefficients. So again, we'll use the number 2 here because it's easy to draw with the mouse. So we have 2, and then we're going to put an x. So we have 2x. So the 2 represents the constant term. In this case, the coefficient is a coefficient of a variable x. Now, in algebra, if there's no operation between two symbols here, in this case a number and a variable, so a coefficient and its variable term, it is implied that it is multiplication. Anything else will have to be notated. Other forms of implying multiplication might be to have parentheses between them. which means that we're going to do everything in parentheses before we multiply. So in other words, we'll apply this coefficient to everything in the parentheses. So everything in the parentheses has to be combined. An asterisk might be put between two numbers or a number and a variable. But typically, if it's going to be a number and a variable, it'll just be treated as a coefficient, and it'll be written as such, or 3y, or any other type of configuration. So we have a coefficient with a variable, and what that means is whatever this variable is, it's going to be multiplied by 3. So we have 3 of this. Now y could equal essentially anything. So y could equal 3 plus 4, okay? Squared, put that in parentheses, times 7. Okay, it could be something like that. So it could be, and like I say, it could be anything. So that just means that whatever this is, we have it 3 times. So clear there. So we've established what a coefficient and a variable term is. We need to look at equal signs for what they are. This will make algebra a lot easier, and I wish this would have been explained to me when I was learning algebra, because I'm pretty simple, so I like things to be pretty explicit. So let's say x equals 4 plus 5. Now, if this is something that we're given right out the gate, we have to assume whatever x is equal to whatever's on the other side of the equal sign. We have to assume it's a true statement in this particular case. So what I mean to say is, as we try to isolate x, so we better add something else to this. So 3 plus x equals 4 plus 5. Now obviously we can see that x is 6, but we're going to pretend that we can't see that. So what we're going to try and do is we're going to isolate our variable term. So we have one variable here, and we need to isolate it all by itself on one side of the equal sign. So you'll hear whatever you do to one side of the equation, you have to do to the other side of the equation. So in this case, we're going to get that x by itself. So we have a positive 3 here added to x. So we need to break it away from the x. So positive 3 we need to bring to 0. How do we do that? Well, we subtract 3. Whatever we do to one side of the equation, we have to also do to the other side of the equation. And the reason is this equal sign has to stay true, because it says whatever is equal here is equal here. So if 3 plus x is equal to 4 plus 5, and if that's true, which we're assuming, then that means x can't equal 4 plus 5, because we've eliminated 3 from it. So both can't be true. It's a very fundamental concept of logic for a young learner, and it starts to develop that logical thinking. It gets them on that path of, if this, then this. If this is true, then this must be true, or if this is true, then this can't be true. And it's starting to establish that pattern of identifying logic. So now we now have to subtract 3 from this side. So we brought this to 0, so now we have x equals, and we don't need to bring that plus sign down because it's implied that it's positive. So x equals 4 plus 5 minus 3. So 4 and we need to remember PEMDAS here, right? I don't know why I capitalized the P and then lowercase the rest. Those are all, we would actually think of them all as capitals. It's a acronym for parentheses, exponents, multiplication, division, addition, and subtraction. So 4 plus 5 minus 3, so we have 9 minus 3, which we combine and know is 6. So we're combining our like terms. So you're gonna hear me say like terms a lot. So these are all like terms. What that means is they're all constants. There's no variables in there. So we're gonna combine these like terms. 4 plus 5 minus 3 is the same as 9 minus 3, which is the same as 6. There's nothing to combine over here because we've gotten x by itself. We've isolated it all by itself, made it lonely. X equals 6. So we just used algebra to solve a problem that we could have done in our head, but the steps we would have taken in our head would have essentially been the same as these. Now you're going to have a temptation to not write out your math, and you're going to have a temptation to do it in your head. My advice is always write everything out so that you can go back and find where your mistakes are, because you will make mistakes. It's just human nature. So write it out so you can see what you've done. Write it out so your instructor can see what you've done in case you've made a mistake. And if you're getting them right, they want to make sure that you're not just getting lucky or not taking some steps that could later on be dangerous. In other words, they might be working now, but as things develop and get more complex, if you've created some sort of a strategy that's not mathematically sound, it could come back to haunt you later. So there you go. That's the intro lesson to basic algebra. So we've covered PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. That is our order of operation. So we're going to operate in this order here. We learned about variable terms, constant terms. We learned about coefficients when we assign a constant term to a variable term in a multiplication fashion like this. We learned about isolating variable terms on one side of the equation and getting all our constant terms on the other side of the equation so that we can combine like terms and isolate the value of the variable term. We talked about ordered pairs, so x, y is the convention for ordered pairs, right? And those give us, together, they give us a single coordinate. They triangulate a point for us, and we do that with several ordered pairs as we look for data and look for patterns, and then we connect those dots and see what the patterns or the data looks like in a graphical form. So that's really the starting point. Let's also remember that we assume positive when a plus sign is not in front of the number or the variable, the constant term or the variable term. And if it is negative, we need to apply negative. And whenever we want to isolate a variable term, we need to do the opposite. So if we have a positive 3, to get that to 0, we obviously subtract 3. Before we stop, we're going to do one more example. So maybe a couple real quick that will come in handy. So let's look at something else. Let's say 3x equals 15. Now, of course, we see that x is 5 because that says 3 times x equals 15. Now, we want to get that variable term by itself. Remember, the first thing we want to do is isolate the variable term. So we want to get it on one side of the equation sign. We talked about the equation sign or equal sign says this is equal to this. And we need to keep that statement true. So whatever we do to one side of the equal sign, we have to do to the other side so that it stays true. We're just balancing. We're just keeping it balanced. And that's the easiest way to think of it, just keeping this equal sign true. So we have 3 times x. So we're going to do the opposite. So we have to get that 3 away from the x. Now if it was 3 plus x, we just subtracted it away. But this is 3 times x, so we're going to think of the opposite right now as division. So we're going to divide it away. And then we're just simply canceling, right? So we're going to cancel that 3 out. And we have x is now equal to, we have to do the same thing over here, right? We have to divide by 3 over here. So x is equal to 15 divided by 3, which is equal to, if you've watched the percentile triangle video, you know that 15 divided by 3 is equal to, or 15 over 3 is equal to 15 divided by 3, which 3 goes into 15 5 times, right? So it's 500% of the value is another way we can look at it. So we could also say that that's 500%, but that's not really true for what we're doing. So we can, I guess we could say x is 500%, but that's not really relevant, and that's kind of digressing. So we're just going to do 15 divided by 3 without getting off on some weird tangent that's like pseudo-true. So we have x equals 15 over 3. So we know that 15 over 3 is 5. So x is equal to 5. So we now know the value of x. So we isolated the variable term here by dividing away. So let's do another one. And this time we'll do, we'll say x